This video will look at example circuit number 3, which looks at wiring up an red, green, blue LED and how to send commands to that red, green, blue LED to make it appear in different colors and even cycle through those various colors. Now, the components we're going to need for this are 3 resistors to limit the current through the LEDs included in our red, green, blue LED, and the red, green, blue LED itself. The red, green, blue LED is essentially 3 LEDs in a single package. As you can see on the schematic diagram here, it shows 3 separate LED symbols inside a box. That's because the red, green, blue LED is just those 3 LEDs inside its own little box. And the box has 4 wires protruding out from it, which conform to the 4 leads that the red, green, blue LED has. And like our red, green, blue LED included with this kit, they share a common cathode. That is, all the currents come out of the LEDs in the same place, which will then be connected to ground. This means that we can hook separate control signals to each of the resistors that will be in series with each of the LEDs inside the red, green, blue LED, so we can control each of them individually. This LED also could have come with a common anode in which they are all connected to power individually. In that case, instead of connecting the cathode to ground, we would connect the anode to a fixed 5 volts and the cathodes to control signals. And we would turn on the LEDs by setting the cathodes to ground instead of high. So for this circuit, we're going to be using ports 9 through 10, and port 9 is connecting to the first resistor to our red LED, port 10 to our green LED, and port 11 to our blue LED. Now, this does make the circuit diagram a bit messy because of the directions that I'm pulling them off from, but you can just as easily change what those ports are in the coding of the sketch if for whatever reason ports 9 through 11 don't work the way you want them to. And finally, we connect common cathode back around to ground. So we're still on the blinking LED simple circuits here, resistor, LED, ground, and a control signal attached to it. The actual circuitry is simple, but the program for controlling it has started to get a bit more complex. So here we've got our program, and the first thing they do is define the pins. Red is 9, green is 10, blue is 11. And that's just going to save that for later so it can be used throughout the entire program. The next global variable they define is display time. And so they're going to have it change the display time for when it's looping through colors. It's going to rotate every 100 milliseconds, so a tenth of a second. And for the setup, once again, we configure the pins we're using for digital output, and then we move into the sketch. Now, the sketch starts off with void loop, and then it calls this function main colors. So at that point, we need to scroll down and look for a function called main colors. So here we are, void main colors. So the first thing the sketch main colors does is turn off all the LEDs. If they were on, they're now off. And then it waits a second. Then it turns the LED on, or the red LED on, and the green and blue off, even if they were already off, waits a second. And then it turns green on while turning red off and telling blue to remain off, waits a second. And then it turns blue on while turning red and green off, and waits a second. Next, it turns on red and green while turning off blue. waits, turns on green and blue while turning off red, waits, then turns on red and blue, waits, and finally turns on all three at once and waits, and then that ends the main color sketch. So the main color sketch terminates, this function line terminates, and it moves on to the next one, which is show spectrum. So if we scroll down till we find a show spectrum, here we go, void show spectrum. So the first thing it does is define an integer x. So this x is going to be used as a counting variable. It's simply a placeholder, and the simple name is something like I or J or K. You use it when you need a placeholder variable or some other way to simply hold a number that will be used but isn't exactly important to save for anything. So next we've got a for loop, and this loop says we're going to start x at 0 and go to 767 and have it increase by 1 each time. And then, while this loop, for each iteration of this loop, I want you to call the show RGB function and give it that value x. And so we scroll down and we find void show RGB int color. And that says it's going to be passed an integer value, which the function will then refer to later as color. It then defines three more variables it's going to be using within itself: red intensity, green intensity, and blue intensity. Moves into an if statement. So if color, this value it's been passed, which in a for loop is going from 0 to 767, then if this is true, the red intensity is 255 minus color, green intensity is color, and blue intensity is 0. So red will shrink as color gets larger and larger, green will grow, and blue is just always going to be off. So the color should move from red to green during this fragment of the program. Next, if color is less than or equal to 511, then red stays off. Green is going to be 255 minus color minus 256. So first we correct for the fact that our value has gone beyond this 256, because later on the command we're going to use to light up these different colors and different intensities accepts input values from 0 to 255. So we need to make sure that green intensity and blue intensity, despite using color, which is now greater than 255, come out to a number that is between 0 and 255. So green starts at fully lit, and then will be subtracted by color minus 256, and blue is going to be color minus 256, so it starts at 0 and is going to increase. So for this segment, red is off, green is decreasing, blue is increasing. So it's going to travel across the color spectrum from green to blue. Finally, if the color intensity is greater than 512, or in this case, just else, because in this program we're not going to pass it any value that is outside parameters we're willing to use. So we don't need an else statement that is a "you have fed me invalid data." Normally for something like this you might use else if color is greater than 512 or color is less than the 767 that is the final value you're terminating, and then you'd write another else case for "you fed invalid data into this," return an error message to the programmer. So the red intensity is going to start turning back on, the green is going to stay off, and the blue is start fading away. So this final cycle, it's going to go from blue back towards red, so cycling around the entire color command. And So now that it's set those intensities depending on what value of color we've fed in, it's going to actually send those intensities out, and it's going to use the analog write command. Now the analog write command, when used with a digital output, only mimics an analog output. The digital output can still only be high or low, yes or no, but it can spend part of its time at high and part of its time at low, so that overall it averages out to what the analog output would be. Now in this case with an LED, that means that the LED is actually going to be flickering so quickly that you can't even see it, but since it's spending part of its time on and part of its time off, it's going to appear brighter or dimmer in the shade that it's lighting up in. If you remember back from the potentiometer experiment, when we turned the potentiometer all the way to where the delay was 0, it appeared to be lit all the time, but also appeared to be lit at a more subdued intensity than it normally is. When we turned the potentiometer back down so that it was actually blinking normally, it was lighting up brighter than when it appeared to not be blinking at all. And that's because we had essentially created a pseudo-analog write function where we were telling it that you spend half your time on and half your time off. So that ends the void RGB show RGB function, which kicks us back into show spectrum. Show spectrum waits for 10 milliseconds, and then continues on the for loop. And when the for loop finishes, show spectrum kicks us all the way back out into our main sketch, which is the end of the sketch, loops us back into main colors. So, if this sketch is functioning correctly, when it's uploaded, the RGB LED should flash red, green, blue, yellow, cyan, purple, white, and then it should cycle through a spectrum of colors starting at red and ending again on red, shifting from red through to green, through to blue, back to red. So, let's switch over to the view of the circuit. Our RGB LED is this guy right here. So, let's upload the sketch and see what happens. Red, green, blue, and these colors aren't exactly easy to tell through a webcam, so I'm going to have to apologize a bit for the quality, and you'll have to take my word for it that it is in fact cycling through these various colors. So red, green, blue, yellow, cyan, purple, white. Starts at red, grows brighter through green, moving into blue, moving into purple, back into red, and stops and goes back to the start of the program again. So this is a way that you can sort of control 3 LEDs with 3 outputs, and also vary the outputs of those LEDs so that they're brighter or dimmer using the analog write function.